welcome to all. This is new series for limit state method. Recently I uploaded for working stress method. First I uploaded for analysis of singly and doubly reinforced sections, then design of shear reinforcement. Now I am changing over to limit state method. First I will consider analysis of singly reinforced rectangular sections, doubly reinforced rectangular sections and also T section by limit state method. Remember, at present, practically you require limit state method only. A proper understanding is very important for any designer. So by going through all this, you can get some quite good idea. And if you are a student studying, this is very ideal for you because all concepts are covered here. But one important concept means there is a limitation. Right now I am running a course for RCC structural design. There, some important part I am uploading in YouTube because in the regularly I take class in Zoom. The classes will be deleted after some time. But if I upload in YouTube, it will be there always, so they can refer anytime. So to give benefit to them, some of the chapters or some of the parts I am uploading in YouTube. Others can use it. Now, limit state method. See, first remember some common part for all above three, whether it is singly reinforced rectangular section or a doubly reinforced rectangular section or T section. In the beginning, some common part. That is some important concepts of limit state method. I will tell one by one now in the order. But some of them proofs I will not tell here. I am giving somewhat like summary. But in the course, I explained each and everything. See, there is a term called minimum here. See, this I can call maximum limit. Or maximum only, no limit here. Because what happens is once I put should not be more than, it is understood. Okay, leave it. There is a term called minimum. There is a term called maximum. Why it is maximum, why it is minimum, very clearly told in the regular course. So that all I can't tell here. But you have to accept it or not accept it. It is correct only. Okay, now start first. Common part for all above three. See, due to bending, we are considering first, see, when you tell beams, it is actually bending. Due to bending, 1 minute, I got a scale here. Okay. Bending can be either sagging or hogging, that will come later. One side will be compression, one side will be tension, if you consider the cross section. Where compression comes in concrete, there will be a compressive strain in concrete. IS code, as per IS code, maximum strain in concrete in bending compression. I will use symbol epsilon C. See, I will not write epsilon C, extreme fiber, etc. You should know it. Maximum comes at the extreme compression fiber. Shall I write it here? See, which will be at extreme compression edge. Okay. It can be top edge or bottom edge depending upon the nature of bending moment. Epsilon C is taken as 0.0035 IS code. Now that is epsilon C maximum for concrete should not exceed 0.0035. Same way, actually this maximum word I don't agree because for concrete there is variation. For steel we don't consider variation. So usually in the class I tell strain. But still IS code has given maximum, okay, understood. Even see, across the diameter also it will change slightly. Ignore it. Strain in tension reinforcement at failure, very important. A word failure is very important. This term I explained many times in the group. I took nearly half an hour for that one. That is epsilon ST. Epsilon means strain in steel in tension. Shall not be less than, very important, Fy by 1.15 ES plus 0.00 to IS code told ES for any grade of steel you take 2 10 to the power 5 Newton per mm square. So this will depend only on Fy value. Next round I will write what is Fy value. Okay. Or this is the EST minimum or minimum requirement. Some odd feeling will come. See, strain is bad. Whether in compression or tension, strain is bad. But IS code tells compression, strain should not exceed. People will agree, yes, correct. Tension, strain should not be less than. Means what? They either want this value or more. Looks very odd for common person. But it has got reason. Beautiful reason is there regarding primary tension failure, etc. This yesterday, I think, yesterday only in the group, I discussed for nearly 1.5 hours. Okay, for you, strain in concrete in compression should not exceed 0.0035. That is a maximum limit. And strain in tension steel should not be less than this value. So now these two values will repeatedly come now. Little later. Okay, now further. In limit state method, strain variation across the cross section is linear. You write, for that matter, working stress method or limit state method, or suppose you start some more method, one more method, your own method, propose it to IS code. If they agree, there also strain variation is linear. The proof for this comes in bending stress theory in strength of materials. Okay. That is same as working stress method. Actually, I tell in the class, irrespective of working stress method or limit state method, strain variation is always linear. But in limit state method, stress variation across cross section is not linear. Reason all I told in the class, you have to accept it now. But remember, in a working stress method, stress also linear. Why? Because we consider stress proportional to strain, it is called elastic method. So working stress method, strain and stress both are linear variation. Limit state method, strain variation is linear. First of all, strain variation is always linear. Okay, this is one part. Now, little bigger I am writing compared to earlier classes all. Therefore, I will remove this one and write the next applicable part. I will write in stages. Okay. Now, next concept. Consider compressive stress diagram for concrete. Details will come little later. Actually, compressive stress diagram for concrete. IS code will use the name compressive stress block. Both are same. See, usually people tell compressive stress diagram, tensile stress diagram, or bending stress diagram, etc., etc. But IS code use the word compressive stress block. Means now onwards, I won't waste time every time. Compressive stress block means compressive stress diagram. That is how the compressive stress for concrete will vary. First, some note you have to write. I have not written here. Understood. You should write here. I will dictate something now. Due to bending, maximum compressive stress in concrete will be at the extreme compression edge. See here. Extreme compression edge. ECE means extreme compression edge. As per IS code, that maximum stress is limited to 0.45 FCK. So now consider sagging beam, top compression, bottom tension. What is this if I call? So many will tell neutral axis. It is not neutral axis. It is not neutral axis. Leave it. It is a neutral surface or layer or plane. Neutral axis comes in the cross section. Okay, leave it now. Now, top compression. So this is the neutral axis. This is in the cross section. See, these diagrams are, you write here. What diagrams I am writing is compressive stress distribution for concrete considering the cross section. Okay. Little later, I will write little later. Now, or I can write here only because why? It is important term. I should write here. Yes, I write here. First, one more thing. Okay. First statement is one XU is depth of neutral axis from extreme compression edge. Common for both. See, this is a common. In limit state method, see, working stress method, we call X. Limit state, we call XU. Is the depth of neutral axis from extreme compression edge. See here, sagging beam. Topmost fiber is extreme compression edge. From there, it is XU, neutral axis. Hogging beam. Bottom is compression. So, extreme compression edge. From here, XU. Okay. Now, this is 0.45 FCK. Here also see 0.45. Because how you mark from top edge here, that you have to mark from bottom edge. Equations will not change. Now, some property. See, what you have to remember is correctly, it is constant for a depth of 3 by 7 XU. How this 3 by 7 we proved in the class. Okay, now, technically it is 3 by 7 XU, but IS code, so many places they use second decimal accuracy, 3 by 7 will become 0.43. Okay. Same way here, see, 3 by 7 is 0.43 XU. If that is 0.43, this is 4 by 7 becomes 0.57 of XU. See, XU is green color today for some reason to identify neutral axis. Okay, now, it is constant up to here. Then, it will parabolically vary, it will keep on reducing and neutral axis 0. So, I written here, maximum compressive stress equal to 0.45 FCK, which is constant for a depth of 3 by 7 XU from extreme compression edge. And thereafter, varies parabolically to 0 at neutral axis. Actually, thereafter, you can write one more thing. Not thereafter what means doubt comes. Okay. And thereafter, compressive stress. Okay. Compressive stress varies parabolically to 0 at neutral axis. This is proposed by IS code. In the regular class, I thoroughly told the reason for this one. Okay. Now, see, now, this is constant, rectangle. Constant means rectangle. This is parabola. Here, see, constant and parabolic. Rectangle and parabola you can tell. Light line mark here. This is, see, don't put Jor and P. Junction of rectangular and parabolic part. Junction of rectangular and parabolic part. You should write that one. Don't write a Jor. Okay. Parabolic part. This is somewhere here. That is, I told you, 3 by 7 XU from compression edge over. Now, you need some extra properties. For this complete stress diagram, see, I told you, for this, see what I am telling, complete stress block, that is, consider the entire depth XU. Here also, consider the entire depth XU. For the complete stress diagram, we want what is the average stress and where is the center of gravity. 1 minute. Working stress method, see, just a note, it was this way. This is FCBC. Average stress at that time was FCBC plus 0 divided by 2. See, FCBC plus 0 divided by 2, or it is 0.5 FCBC. 0.5 FCBC, but there you put FCBC by 2. Its centroid will be here. Red color, see. Red color required, okay, not required. This here, this, that much you can make out. Okay, centroid will put red color. Its centroid is here, G. This distance is 1 by 3 of X. By working stress method, you take this as X. I am showing for sagging BM. See, I am marking for sagging BM, hogging not required, X. This is working, or if you want decimal form, it is 0.33333 XU, you can tell, more accuracy. No XU, X, okay, X. Because it is linear. Now, this is not considered in limit state method. See, limit state method, the variation is constant here, parabolic. So, it is not like working stress method. Just 1 minute. Suppose it is linear. See, make a note. If it is this way, by chance, if it is by chance this way, then average will be 0.45 plus 0 divided by 2. It will come 0.225 FCK. No, because more area is there. See, if you go as per working stress method, it is half of the maximum value, average. Here, half of maximum is 0.225. That is only if it is linear, but it is not linear. You got rectangle and parabola. Therefore, remember, we derived in the class. In the class, we derived it. Average is little more. It is not 0.225, little more. It is, see, where written? Average stress, somewhere written. Average stress, where here, see, I wrote here. It is 0.36 FCK. So, for this complete stress block, see, complete stress block, average stress equal to 0.36 FCK. Here also, I'll write here, for complete stress block, average stress equal to 0.36 FCK. You take two screenshots, one without marking, one with marking. Okay. So therefore, one concept over now. Second concept. If it is linear variation, 1/3 or say decimal format 0.33333. Here, it is not 0.333 because why? You can see here, it is 0.3333 of XU if it is linear, but little more area is there. So CG will slightly shift towards what? Neutral axis side compared to working stress method. So CG is here, see red color. Make a note here. In today's explanation, what I have done? Red color I used for CG. Oh, good catch. Red, I caught it. Red color I am using for centroid G. Either you call centroid or sometime I call CG. Both are same. See. But important, it is not 0.333, it is 0.42 times of XU. Here also, 0.42 times of XU. Okay, now, one small important information. This is, see, the constant is for approximately 0.43 XU. This is 0.42 XU. So, difference is only 0.01. So, if you look at the IS code, you cannot make out clearly. It is, see, that 0.01 of XU difficult to mark. So, IS code, they have shown an arrow mark there. That arrow mark is actually for what? Line of action of the force. Line of action of the force always passes through centroid. Therefore, IS code has given that 0.42 XU, it is not junction. So many people, what they think is, they think it is junction. I'll tell you here, see, IS code, how they printed is, they printed like this. Then they show an arrow mark here, this way. And they told, this is 0.42 XU. So many people, if they ask, they will tell, oh, rectangular portion is 0.42, remaining is parabola. No, IS code is not bothered about the junction. This arrow mark shows it's a force. Resultant force passes through CG. Therefore, what they are giving IS code is actually centroid location. Remember, 3/7, 4/7, they are not told. It is derived by us. Okay, now one more note. In the offline class, I will ask. So CG lies. I will ask them, will it compare to the junction? See, this junction line. Is CG slightly above or below? I will not write this question, this one first. Within no time, all will tell, sir, slightly above. No, you should not tell above, below, because, see here, CG is slightly above. Why? 0.43, this is 0.42. But see here, it is 0.43, 0.42, CG is slightly below. Therefore, correct answer is CG lies in the rectangular part. At the rectangular part, if you locate the CG from extreme compression edge, you come by a distance of 0.42 XU towards neutral axis, you get CG. A little further you go towards neutral axis, you get the junction. See here, from extreme fiber, first come by 0.42 XU, which is in the rectangular part, you get CG. little further towards neutral axis, you get junction. Hope this is fully clear. Make all these notes because it is important. For solving problems, formula will be there, but understanding correctly is very helpful. Okay, now I will go to next round. Continue. As already given, xu is depth of neutral axis from extreme compression edge. See here, 1 minute. D is the effective depth. This you already know because working stress method I told, but still is the distance of centroid of tension steel from extreme compression edge. Then epsilon c is compressive strain in concrete at the extreme compression edge. That is the maximum compressive strain. Epsilon st is strain in steel in tension. Now consider strain, one more thing. Also told strain variation across cross section is linear. Now consider strain variation across cross section. See, sagging beam, compression tension, epsilon c linearly goes to here epsilon st, this xu, this is d minus xu, centroid of tension steel from extreme compression edge is d. Same thing here, epsilon c, right side I am writing compression, epsilon c, epsilon st, d, xu from here. Now, one important property. From similar triangles, either use this diagram or that diagram. Epsilon c divided by xu equal to epsilon st divided by d minus xu. You cross multiply this one, simplify, this I did in the class. You will finally get xu, we get, see, very important, no, not a green color, green is for neutral axis. Then we get, red is coming, see, when I want some color, some other color is coming. Then we get, and very important equation, that is, this value will come. I am using bracket here for some reason. See, the bracket is very useful for you. I'll tell you later. Simplify, you will get xu by d equal to epsilon c divided by, it is a ratio of xu to d. There is no unit for this one. Strain also no unit. Or how to remember it? Ratio of xu to d is numerator, extreme fiber compressive strain. Denominator, extreme fiber compressive strain plus strain in tension steel. Or if you go to my class of mathematical concept uploaded there, 3 classes are there. In the playlist you can see there, in the first class only I told this one. You can go and refer that one. Okay. This we get for, now this is very, very important. Now see, further. Now what you are doing is, see, little later, I will tell now. Little later, we will consider very important, now is red color required. Balance section, all red color, balance section, comma, under reinforced section and over reinforced section. Over reinforced section. Right here. At that time, for, because I can't compare, for balance section, we will take, we will consider whatever is your xu, that xu as xu max. Then we need xu max by d, a term called xu max by d, for which use this expression. At that time, we'll be knowing how much is epsilon c you have to substitute, how much is epsilon st you have to substitute. Therefore, at that time, I'll simply write the equation. We already know it. Use this one to decide or not to get the value of xu max by d, a very powerful term. Ratio of depth of neutral axis to effective depth for a balanced section. Okay, now, just for information, first to take a screenshot of this one. Don't disturb the diagram. Take one more screenshot. If you draw a compressive stress diagram now, it will be like this. See, CG will be somewhere here. Average will be 0.36 FCK. If you draw here compressive stress diagram, it will be like this. Average, you know it, this is 0.45 FCK. This also, just second time you are right, 0.4 FCK. Average is 0.36 FCK. CG at 0.42 XU you require from here. Just make a note second time. This will give one more concept. Now, I will go for today's class last part. I decided to give all the basics in details, not hurry and write everything in a single stretch. So, this is class 1. Even class 2 and class 3 also may be some important concept. Then I will change over to singly reinforced rectangle section, doubly reinforced rectangle section and T section. So these all you have to go through. See, what all I am telling now, it is valid for everything, right here. So far, I write next time I write. So far, what I told is valid for singly reinforced or doubly reinforced rectangle section and also for T section. Now, we will define balance section. Under reinforced, over reinforced, we will define later. Second round. A balance section, red color, because I wrote black color, I underline, is one in which area of tension steel provided is such that when the maximum compressive strain in concrete, epsilon C, reaches 0.0035, you already know this number, simultaneously means at the same time strain in tension steel will reach Fy by 1.15 ES plus 0.002. See here, sagging BM, top compression, bottom tension, XU from here, D is from here, extreme compression edge. Hogging BM, bottom compression, top tension, D from here, XU from here. And also for a balance section, what we considered XU, we will consider it as XU max, in future red color. Reason for red I will tell you later. This is for a balance section. Now, what you have to do is some expression for this XU max by D is required. That is universal. It is for singly reinforced or doubly reinforced or T beam, everywhere same. I will write that one now. See. Therefore, now see. Therefore, for a balance section, this color problem always, see. Therefore, for a balance section, if we substitute epsilon C equal to 0.0035, then epsilon ST to be substituted is Fy by 1.15 ES plus 0.002. And also, wherever your XU comes, and substitute what? And also substitute your XU equal to XU max. Now, see, we already got what general XU by D equal to we got what equation? Epsilon C divided by epsilon C plus epsilon ST. I use bracket for this one for some reason. Just now we got it. Therefore, this value you substitute for balance section. Substitute for balance section. I will remember now. I am removing everything now. So when I go to next round, you cannot see anything. Remember, where XU is there, put XU max. Where epsilon C is there, put 0.0035. Where epsilon ST is there, Fy by 1.15 ES plus 0.002. I will write a big note and give some information for it. Okay, now, therefore, for a balance section, just now I wrote, substitute XU equal to XU max, epsilon C equal to 0.0035, epsilon ST equal to Fy by 1.15 ES plus 0.002. Just now I told your XU, oh sorry, I forgot right here. Oh, please. XU max, I forgot right. XU max by D equal to 0.0035 by 0.0035 by Fy by 1.15 ES plus 0.002. See, some number divided by same number plus something which depends on steel. You can make out here E of steel is 2 × 10⁵. So XU by D is a ratio of distances. It is unitless. And see, everything is constant here. ES also constant. Only variable is Fy. So XU max by D depends only on Fy, that is steel grade. If you remember working stress method, I will tell you, I wrote Xc equal to Kd, where K equal to 280 by 3 divided by 280 by 3 plus sigma St. See, concrete property by concrete property plus steel property. Concrete property is constant, or a constant divided by same constant plus something to do with steel. A constant divided by same constant plus something to do with steel. Now, some note you are right here. This equation, some will tell, sir, IS code has given. Wait for some time. Don't be in a hurry. Sometime in the class they will tell, sir, why sir? It is given IS code, but wait for some time. I will tell you why. Sometime competitive examination, they give trouble to you. Okay, now start. How to remember this one? First of all, why you require remembering, I will tell you. So, majority, this much I explained. If you understand everything by this time, it is already by hearted, I think. Or, if you got difficulty, IS code, I noted down page number 69, right side, see, top you can see IS 45, don't see that one. Top, right side, if you see from top reading, you can see a number there. Top number is 0.0035. Come down, bottom you can see an expression. See there, Fy by 1.15 ES plus 0.002. Therefore, page 69, right side, you can by heart it, remember easily, XU max by D equal to top number divided by top number plus bottom expression. Sufficient. Okay, now, just now I told your XU max by D depends only on Fy. Consider mild steel. This all I am giving next time. Fy 250. Substitute Fy 250 here. You will get this much answer. This all you can do it now. Then substitute Fy equal to, this all I will explain next time. Fy 415, you get this answer. Fy 500, you get this answer. Now, make a note. Come this side. What happened is, IS code decided. Why unnecessary remember all the equation. So what they have done is, only for these three steels, 250, 415 and 500, they are given a table. Page number, you search. So they told FY 250, how much? They rounded to second decimal. Therefore, one note. In class, now onwards, make a note. If you are using either FY, if you are using mild steel of FE 250 grade or tar of grade FE 415 or tar of grade FE 500, we will not bother about all these things. We will directly write from IS code what is X max by D. But see, suppose a new, at present new steel has come, FE 550, what to do? Some will tell, sir, interpolate. No, don't go for interpolation. When the formula is, when the expression is known, you should not go for interpolation. You have to go for forward interpolation. No, don't go for it. Therefore, make a note here. You should write what all I tell you, write. If the FY in the question, either in examination or competitive examination or new steel used market, FE 550 comes or FE 600 comes, then what to do is, if any steel is considered other than these three, use the basic equation. I told you how to remember. Then what to do is, suppose FY, sometime in competitive examination they will give, take FY 400. You cannot question them, why 400? You will tell 400. If you substitute, you will get 0.48. No, you may get 0.48 or very near to this number. So it will again become 0.48. Therefore, what to do is, if any other steel is used, better use one more decimal to distinguish them from these three values. Make a note. Also, what all I told from today, this class beginning up to now, is common for everything. It is for limit state method. It is not for singly reinforced, doubly reinforced or T-beam. It is common. So till I start singly reinforced section, whatever I tell is common. So that is all these are valid for singly reinforced, doubly reinforced section and rectangular sections and also T sections. Okay, I will continue in the next class. Thoroughly go through each and everything.